I just got a message from my SMS application. It says that it's being encrypted. I know what happened. I'm using this end-to-end encryption application because it allows me to communicate with my friends securely. How many of you are using those securely in your applications like Snapchat, maybe Instagram, or other applications that sends message to your friends? This is the Hacker's Corner. Hi everybody, welcome back. This is the Hacker's Corner. My name is Cristian Servín. I'm an associate professor in computer science here at El Paso Community College. I teach the courses of computer science, information technology. Some of them they have to be with cybersecurity and intelligence systems. And right now we have a show that we have been prepared to you based on cryptography. This is the second part of cryptography. We already discussed previously in other shows, in other episodes, how to use encryption in your day-to-day basis. Let me just friendly remind you that all mobile devices like this one, your cell phone, your tablet, your computer, every time you send an email from your point A to point B, it has to be encrypted. As you probably already know, there's a lot of these attacks nowadays that have to do with encryption and not encryption, or actually the data that is being stolen is never encrypted. One of the examples is when someone has access, an adversarial has access to a server or to the cloud or some kind of services, the very first thing that they check if that data is being encrypted or not. So we have received feedback from our users saying, can you talk a little bit more about ransomware, because it has to do with encryption. We will have a show just devoted about this particular attack called ransomware. For those who don't know, ransomware is an attack, it's a cybersecurity attack that basically once they get access to your system, starts to encrypt information. Encryption, if you remember, is this art, this is mechanisms to hide information. So you don't see it, the plain text right away, you just see gibberish, or you can see other kind of information there, but not the data that you're expecting. Ransomware is one of the examples of this cyber attack that uses cryptography in order to hide all that information, and you cannot have access to that information unless you pay some monies or some demands from these adversarials. So one of the things that we have discussed previously is how encryption works. And today we're going to continue with this episode as the part number 2, which is more about the asymmetric and symmetric and hashing techniques. Previously, we talked about the Caesar cipher as a way to have a symmetric encryption. And we talk about why we need encryption. And just in case you forgot, let me show you right now here on the screen that when you have two individuals who would like to communicate, or it doesn't have to be an individual, it can be you or your device trying to send an information from point A to point B, what they want to do is to send a message. It can be any message. It can be your password, it can be your account number, it can be your telephone, maybe a message, maybe something. Ideally, you send that information from point A to point B. Ideally, as I mentioned, but in reality, what happens? It happens that sometimes when you send that message can be intercepted by a third party, also sometimes called man in the middle. So this is an adversarial who probably have in mind you as an asset, or probably just want to know what's happening in a network. Typical scenario on probably in a coffee shop when you just go sit down there, get your coffee and free Wi-Fi, you connect and send a lot of sensitive information like your bank accounts, maybe your telephone numbers, your social security, hopefully not, by the way. But then that information can be intercepted by this third party. We talked about that needs in previous episodes. So I'm going to encourage you to go to the EPCC YouTube channel in case you haven't watched it here in air, or if you're watching here online, please go and check the previous episodes that will talk about that. So we already talked about that need, and we are aware because as you can see right now in the screen, there's a lot of unfortunately events that they get caught big enterprises, big corporations. They lose thousands of dollars per year because information is not encrypted. I don't care, professor, I don't have a company, I don't have a corporation that I have to worry about. And so what? Well, guess what? You have one of these devices. You have a mobile device. I think everybody has one of these days. So you also need to be aware. As I mentioned, I just received a message from my friend, and it receives here, it says that end-to-end encryption. What does that mean? It means that this application that I have right now established a channel between my communication and my friend, and I send all that information through this tunnel. Let's call it tunnel, and it's encrypted. The question is, how can you encrypt? So we talk about different forms of encryptions, but today we're going to talk about this particular tool called the OpenSSL. So basically, this is a software library that you can use in a Linux environment or maybe in a Windows environment as well. And I think it's mostly under Linux. So what is Linux, professor? I have heard good things, bad things, hacking things about Linux. Well, Linux is an alternative operating system. As a matter of fact, it's an open software. It depends on what kind of version of distribution you have. But Linux has this open, and it's free, by the way, in some of them. There's other versions who are a little bit more commercial, but you can do a lot of applications and related with cybersecurity. In particular, Kali Linux is one of them that they contain all these tools that you can use in order to introduce cybersecurity tools and whatnot. One of them is OpenSSL. And this library has already enough material, enough libraries that they can help you out to encrypt. So today, let's take a look at that. I'm going to run a demonstration in my computer right now. Hopefully everything goes right. Everything goes right. Did I say wrong? Hopefully not, but everything goes right and not wrong. And hopefully when we encrypt that message, you can see the output, which will be a decrypted message. Let's take a look. I'm going to use something called the terminal. We talked about the terminal in previous episodes, but the terminal helps us to access the operating system based on this console. A console basically is this box that you can see here. Everything you can do, or everything that you can do in an operating system like Windows, like drag and drop, double click, whatever you want to call it, it can be done by using this terminal. As you can see, currently I'm in the desktop. I'm going to zoom out, but this is my desktop. As you can see in the back, you can see all my folders. You can see a little bit of my files there. So what I'm doing right here, if I type ls, which is listing, you can see the folders, and actually more in particular ls-l, you can see not only the list of folders that I have there, but also if it's a directory or if it's a file. And also you can see in the left-hand side, I hope everybody can see this or appreciate what I can show you right now. It has something called the file system attributes. In cybersecurity, this is critical because it shows you who can read, that's the R, write, W, and X to execute. Those are the three attributes that you can see or you can always have to consider every time you're dealing with a file or a directory in an operating system. Read, write, and execute. Now, there's a couple of those items that we need to consider also if you're dealing with super user, if you're using for your account of our group, or for everyone. So Linux gives you this hierarchy of different kind of accessibility if it's for everyone, the public, or a group, or a corporation, or if it's only individual or super user. Okay, that's something that Linux always taking care of that. Not only Linux, I know Windows users, they have the same situation, but I just want to make sure that you understand that there is this file attributes here. Now I'm going to clear my screen. So right now, what I'm going to have here, as you can see, I have a file called test. So I'm going to have here test, and it gives you a small description what this thing is. It's a text file that says, hello, this is a test. For each line and each token, that information is hidden. It's just a silly text that I wrote there just for these purposes. Now, the application that I told you is called OpenSSL, and that's basically gives you this library in order to execute specific libraries for encryption. And we're going to show you how this works. Now, if you can see in my desktop, and I'm not so sure if you can appreciate that, here is test. I'm going to click here. You can see the same text that I was using. I'm going to execute this command that I'm just telling you. Let me zoom in and let me show you this particular command. I'm going to open SSL and I'm going to use this algorithm called AES-256. I know there's a lot of encryption here going on and that text is encrypted, but in reality that means that there's 256 bits in order to encrypt this particular algorithm. Then we have something called the salt, and salt helps us to randomize some information in order to make it more secure, in order to not be so trivial to decrypt. So salt is widely used in cybersecurity to sprinkle additional information in order to actually make it more complex to decrypt. The next thing is the command that we're going to encrypt. And this is the test.txt that I actually mentioned. That's the text file that I have in my desktop. I'm going to generate an output file. That's why I put -out. And I'm going to put here secrets.txt.enc for encrypted. When I hit enter, ladies and gentlemen, it's going to ask me for a password. This is where you generate your key. Okay? Sometimes it's called private key, depending on where you actually using this terminology, but in reality, this is the key that you're gonna decrypt eventually. I'm gonna, only for educational purposes, I'm gonna type here EPCC. That will be my password. It's asking you right now to re-enter the password only for verification purposes, and I'm gonna put here EPCC again. Now I'm gonna zoom out right now, and I'm gonna go to my desktop. Check this out. It generates the file that actually I was expecting to generate. It's called secrets.txt.enc for encryption. I'm going to right click here and I'm going to try to open with my text editor. And I want you to pay attention what this information got encrypted. Wow, check this out. All that information is being encrypted in bits. So this is the 256 AES algorithm that we were discussing previously. It got encrypted like that. So now you can send that information to your friend through anything that you actually using, for example, Instagram or even a messenger through Facebook. I don't know. Whatever you're using there, this is one way to encrypt it through something called the private key. So when your friend receives this information, now your friend can decrypt this information and give you the solution. Now that we have this encrypted message, how can we inverse the encryption and get the original one? Now I want you to pay attention. I'm going to close my file real quick. I want you to understand that in my desktop I only have the original one, test, and then I have the secrets that got encrypted. Now I have no other file, and I know it's going to look like magic or whatnot, but when I go back to my terminal, I'm going to use the following command. Basically, is again an open SSL, and then this time I'm going to use secrets.txt.enc as my input, and I'm going to generate an output called new.txt.new. As a matter of fact, why don't we just call it that new.txt? When I hit enter, it's going to ask me to enter the password. Do you remember the password that we create that thing? It was EPCC. By the way, don't use EPCC. It's a beautiful name, but very weak password. So only for the purposes of this, we're going to use EPCC. We hit enter, and I don't know if you noticed, but magically appears inside of my desktop this file called new.txt. By the way, magic and computer science or cybersecurity, there's this fine line to distinguish between wizards and computer scientists. We actually do a lot of magic, but in reality, software engineering. This is what we just seen is all file systems, and we manage those whole situations. So that magical file that we just saw there, in reality was the generation of that file using this tool. Now, if I click here and I try to read, if you notice, there was actually no surprise, but this is the original one that we encrypt at the very beginning. Hello, this is a test for each line, and each token, that information is hidden. It's a very silly message, but that kind of demonstrates the whole purpose of this tool. It's a beautiful tool, very effective. As a matter of fact, now you can encrypt your files just to keep them in secure order. Just don't forget your password. Otherwise, I don't know, we have problems, right? And no one can help you out because it's been encrypted, and that will be a different challenge. So now that you know how this tool works, now you can actually understand how that system works behind the scenes. Let me talk about another technique that is being widely used these days, not because of the reason that you think is secure, is because that is another technique to search items very fast, and it's called hashing. Hashing is an alternative way to hide information or to encrypt information, if you may. But it's not based on an algorithm that you basically use like RSA or AES or some other symmetric or asymmetric. Hashing is the process of receiving any kind of string or any text, and then based on the configuration will always generate the same length of the hash based on the algorithm that you use. We're going to use a tool right now that is online about all these different hashings that you can see right now. There is an open project called GitHub, and some of you might have heard about GitHub, but that's the community. It's a service that the whole community, they put information there for the community purposes. We can extract information, we can share information, we can share all these products. So let's take a look at the following application in GitHub that will correspond about hashing. You have heard about hashing in the past because of your hashtag, or I don't know. I mean, it's a different kind of perspective about hashing, but in reality, hashing helps us to understand integrity. It's one of the things that is widely used. Hashing, for example, in searching, it helps to find things very fast. That's why when you see hashtag EPCC, it will go and list you in the social media, YouTube, everything that corresponds to that hashtag EPCC will collect that information for you, and it will display in seconds, nanoseconds as a matter of fact. Why? Because when you generate a hashtag, will generate a unique number that will correspond to that particular concept. In this case, will be EPCC. You put hashtag Hackers Corner, it will list you all the episodes that are being using for the Hackers Corner. So you can use that thing. I don't have to tell you anything because everybody, these new generations, all of us, we use this device in order to hashtag your friends, hashtag your events, hashtag, I don't know, the places that you check in, and everything gets compiled for you in seconds. Now, having said that thing, the same principle has been established for cybersecurity in terms of encryption. So where we're looking right now, we have all these algorithms in the left side that corresponds to these hashing algorithms. The most popular ones are MD5 and SHA-128 or SHA-256. Now, we're going to use here the input. Again, this is an online tool. I have no authority. It's an open source platform that people can use only for educational purposes. But for example, I'm going to type the word hello here. I want you to pay attention how it generates this value, 32 characters based on hello. Now, if I put here hello, yellow, forever, I don't know if you notice, but still 32 bits there, but the different change, the hash changed because every time I introduce a new character, the entire hash changes. And this is very, very effective, surprisingly super effective, because it will generate that unique piece of information based on the string that you have using MD5. So MD5, just for clarification purposes, is a hashing algorithm that will generate hashes of length 32, regardless how big that information is. We can put here yellow, I forgot the forever, EPCC, Hackers Corner. And even if I put more stuff here, it will always generate a 32 length. It's very impressive, by the way. Now, MD5 was popular during the past decade, but the more information we introduce to the internet, the higher the length it will be, and might got collisions. And collision is when you have the same size or the same hash for different values. It's rarely to happen, but it has happened in the past. Collisions, basically, let me repeat that thing, is when two different values have the same key. So that's why you increase the size of the potential hash based on that. And as you can see right here in the left side, there's plenty of them. As a matter of fact, I'm going to use SHA-256. So SHA-256 basically will generate a larger key. Let me just put here hello. This is another text in different hash algorithm. I don't know if you notice, but now it's even more length. It's lengthy, 64. So this is twice as MD5. So it's a little bit, it's twice the size of MD5, and it has more possibilities when you have, because it's 2 to the power 64, which is a lot, by the way. So 2 to the power 10 is 1,024 possibilities there. Can you imagine 64? It's a lot. So the whole is called message digest. That's why it's called MD5. Message digest help us to have a message, it goes digested, and it will generate this fixed size of the hash. So SHA-256, 128 gives you a little bit more expansion. And it's a different algorithms, as a matter of fact. So that helps us to keep information safe, information hidden, if you may. So the only thing you need to do is to understand hashing, and now any applications compares hashing versus encryption. What are the advantages or disadvantages of encryption? In encryption, you need to know a key always, like your password, right? But for example, with SHA, you don't have to worry too much about that because it will generate them automatically. You have seen this before. As a matter of fact, when you go to Google or two-way authentication, sometimes it suggests you to get these particular passwords. These passwords are automatically generated by these tools because they're actually pretty much, they're called password managers, and there's plenty of them, by the way. But the one from Google, they're widely used because they use this high technology and secure technology in order to protect your passwords. And in reality, nothing is 100% secure unless you actually are completely disconnected from humanity, and even still that. I still question those perspectives. But in reality, this is one way to protect that information by using encryption and by using hashing. So we have discussed a lot of things, and we can unpack a lot of those things. I want to invite you to take a look what we're doing at EPCC. We have a great program in cybersecurity. We're infusing cybersecurity concepts in the curriculum of computer science, in IT. Also, we have great facilities right now where you can write a lot of programs. You go and play with these machines that are being devoted for networking, firewalls, intrusion detection systems. And we have a great faculty who has been working very hard to create these programs in cybersecurity. Now, in the aspect of computing, computer science is where we generate the algorithms. So this is my question that I receive mostly every single day. Professor, I want to be a hacker. And again, to be a hacker doesn't mean that you're going to be a malicious person. It means that you're going to understand everything that entails computing, from input all the way to output. How do you connect to interfaces? How do you connect to the cloud? How do you write the code to be secure? I always tell my students that I do generate hackers in my classrooms, ethical hackers. We actually are responsible to recognize these responsibilities in communities, in the society, because we're going to write programs that actually change the world, change the route, how the world is going. And of course, in the classroom makes a lot of difference there. So we would like to invite you to join to the programs that we have here at EPCC. I promise you that we will generate hackers from you, but ethical hackers, so you can see the difference and keep balance in society. The programs that we've been writing here can be found here in this link. If you liked what we have done so far, you can download for free. Again, this is only for educational purposes. I want to go and invite you to go and download, give us a feedback, like this video, like this channel, of course, share it with your friends, share it with anyone who is watching right now, with your friends from high school or your colleagues. Send us an email, tell us, Professor, we do like your show. Professor, you should pay more attention on this. Have you considered this? That feedback that you give us is great. I want to thank all of us, all of you actually, who have been watching and sending us these messages constantly. I want to thank my students and everyone who has been helping me to generate these episodes. And hopefully we continue that in the near future. My name is Christian Servin. I am very happy to be here with you in another episode. I'll wait for you next time in another great show of the Hackers Corner. Meanwhile, happy coding and see you next time.